morning. My name is Narsimha. Generally, if we observe I will explain about one example. Generally, if we throw an object in upward direction, it reaches maximum, it reaches certain point and falls back towards the earth surface. Why this object is coming back to the surface of the earth? Why it is not moving away from the why it is not moving into the space? Why it is coming back? And one more example. The raindrops always falls towards to the surface of the earth only from the clouds. The raindrops falls from the clouds towards to the surface of the earth only. But this raindrops does not move above the clouds in upward direction. This raindrops does not move in upward direction. Why the raindrops are coming towards to the surface of the earth only? Why it is not moving away from the earth? Next. Generally, all the planets revolves around the sun in their particular orbits. The planets does not move away from the sun. These all planets revolving around the sun in their particular orbits. These planets does not leave their orbits. Why it is not moving away from the sun? This all phenomena are occurring due to the gravitational force. Generally, when we leave this object, if we throw an object in upward direction, after reaching a certain point, it comes towards to the surface of the earth. That is due to the gravitational force of the earth only. The raindrops falls towards to the surface of the earth. That is also due to the gravitational force of the earth only that water drops are coming to the earth's surface. Here, due to the gravitational force of the sun only, all planets are revolving around the sun in their particular orbits. If there is no gravitational force of the sun, that all planets does not revolve around the sun. It moves in their particular paths, in their own paths. So here, these all phenomena are occurring due to the gravitational force. Either maybe it is gravitational force of the earth, either maybe it is due to the gravitational force of the sun, either maybe it is due to the gravitational force of any other planets. These all phenomena are occurring due to the gravitational force. What is meant by our topic name is gravitation. Our topic name is gravitation. What is meant by gravitational force first of all? Gravitational force. Gravitational force is nothing but in the universe, if we take any two objects, either maybe this, I am taking these two objects, one is chalk piece and one is duster. In the universe, every object attracts with some force towards it. In the universe, every object attracts by the another object with some force. In the universe, every object attracts by the another object with some force. This force of attraction is called as gravitational force. Here, if we take these two objects, chalk piece and duster, some gravitational force exists between these two objects. This chalk piece attracts duster and this duster attracts chalk piece towards to each other. But these two objects does not move closer to each other. Why? Because the gravitational force of the earth is larger, is more than the gravitational force between these two objects. Generally, gravitational force exists between these two objects, but does not attract each other, does not move each other. Why? Because the gravitational force of the earth is more on these two objects than gravitational force between these two objects. That is why this two does not attract, but some gravitational force exists. Gravitational force is nothing but the force of attraction, between others. In the universe, every object attracts by the another object with some force. This force of attraction between two objects is called as gravitational force. In the universe, every object attracts by another object. The force of attraction between two objects is called as gravitational force. Here, when we leave this object, this chalk piece, it attracts by the earth. Between these two objects, earth and this chalk piece, some attractive force is existing, right? That attractive force is called as gravitational force. Next, the second one is gravity. Gravity is the special case of gravitational force only. What is meant by gravity? Generally, here the attractive force exerted by the earth, the attractive force exerted by the earth on any object near the surface of the earth, is called as gravity. Gravity is nothing but generally the gravitational force exists between any two objects, but in the case of gravity, the gravitational force is exerted by the earth only. The gravitational force is exerted by the earth on any other object near the surface of the earth is called as gravity. Gravity is nothing but the force exerted by the earth. Gravitational force is nothing but the force between any two objects. The attractive force between any two objects is gravitational force. But gravity is nothing but the attractive force between earth and any other object is called as gravity. In the case of gravity, one object we should take as earth. We should take that in the case of gravity, in the two objects, one should be earth. Should be earth. That is gravity. The attractive force between earth and any other object is called as gravity. Now we will see the acceleration due to gravity and okay. Acceleration due to the gravity. Acceleration due to gravity is nothing but, generally, first of all, we should discuss about the acceleration. What is mean by acceleration? Acceleration is nothing but the change in velocity of an object per unit time is called as acceleration. The change in velocity per unit time is called as acceleration. Here, velocity is changing. Generally, acceleration due to gravity means the acceleration gained by the object due to the gravitational force of the earth. Acceleration gained by the object due to the gravitational force of the earth. Gravitational force of the earth is called as acceleration due to gravity. Acceleration gained by the object due to the gravitational force of the earth is called as acceleration due to gravity. What is meant by it? Now I will explain with one example. I am rubbing this. Okay. For example, I am leaving this chalk piece. I am leaving this chalk piece from a certain height. Initially, it is in rest position. There is no velocity. It is in rest position. There is no velocity. But if you leave this chalk piece, it travels towards to the surface of the earth. It travels towards to the surface of the earth. So here, see, initially the velocity of the object is 0 meter per second. There is no velocity. It is in rest position only. But if you leave this object, it moves towards the center of the earth. It moves towards the center of the earth with some velocity. Initially 0 meter per second. But after 1 second, this velocity becomes 9.8 meter per second. 9.8 meter per second. In second, this velocity becomes 19.6 meter per second. In third second, this velocity becomes 29.4 meter per second. For every second, the velocity of this object is changing. Why? That is due to the gravitational force of the earth. Generally, we discussed the acceleration due to gravity value is 9.8 meter per second square. It means for every second, the velocity of an object is increased by the factor 9.8 meter per second. For every second, the velocity of the object is increased by 9.8 meter per second. So that is why the velocity initially it is 0. In 1 second, gain 9.8 meter per second. In second, 19.6. In third second, 29.4 meter per second. Here, velocity of this object is changing. Velocity of the object is changing for every second. So the rate of the change in velocity per unit time is called as acceleration. It means it is moving with acceleration only, right? Why? Because velocity is changing for every second, right? This velocity is changing. Why this velocity is changing? Due to the gravitational force of the earth only it is changing. If there is no gravitational force, it moves with constant velocity. Due to the gravitational force of the earth only, the velocity of the object is changing. So this change in velocity due to the gravitational force of the earth is called as acceleration due to gravity. Acceleration gained by the object due to the gravitational force of the earth is called as acceleration due to gravity. This acceleration is gaining by object due to the gravitational force of the earth only. It is called as acceleration due to gravity. gravity. Now, we will see the acceleration due to gravity of the earth derivation. Acceleration due to gravity of the earth. Now we will see the acceleration to derivation of acceleration due to gravity of the earth derivation. For that, initially, let us assume that earth is in the shape of sphere. Earth is in the shape of sphere. Earth is in the shape of sphere. Generally, earth is in the shape of sphere, only solid sphere. I am considering the earth is in the shape of the sphere, and this sphere is divided into the large number of spherical shells. This sphere is divided into large number of spherical shells. These all spherical shells are concentric spherical shells. These all spherical shells are concentric spherical shells. It is nothing but, generally what is meant by concentric circles? If all the circles have same center point. If all circles have same center point, then that circles are called as concentric circles. Here, if all the spherical shells have one common center point, then that spherical shells are called as concentric spherical shells. Now, I am considering an object on the surface of the earth at point P. The object mass is small m. I am considering an object on the surface of the earth at point P. This object mass is small m. Here, the total mass of the earth concentrates at the center of the earth. So, this center of the earth is called as center of mass. This is called as center of mass. The distance from center of mass to mass of the earth to point P is equals to radius of the earth only, right? The distance between this center of mass to point P is R. Total mass of the earth is m. Now, I am considering the acceleration due to gravity. The gravitational force acts on this point P due to the total mass of the earth. Why? Because this point P is on the surface of the earth. That is why, due to this total mass of the earth, the gravitational force acts on the point P due to the total mass of the earth. Now, if we consider point P inside of the earth at a depth d, if it comes, I am considering point P inner side at a depth d from the surface of the earth. Now I am taking this distance from the center to point P is small r. When the object on the surface of the earth, the gravitational force acts on this point P due to the total mass of the earth. But when we consider the point P inner side of the surface of the earth at a depth, the gravitational force acts on this point due to the inner spherical shells, mass of the inner spherical shells only. The gravitational force acts on this point P. Due to the outer shell, due to this outer shell, the gravitational force does not act on this point P. Why? Because if the gravitational force acts due to this outer shell, this object should move towards to the surface of the earth, right? But gravitational force of the earth always acts towards to the center of the earth only. That is why the gravitational force acts on this point P due to the inner shells of the inner shells from the point P, inner shells of this point P only, the gravitational force acts on this point due to the mass of the inner shells. Clear? Here total earth mass is ME. The distance between from center to surface of the earth is RE. Now when we consider the point P inner side of the earth at a distance R, the distance between center of mass to point P is smaller, and the mass of these inner shells, is M. Now I am writing here total mass of the earth, total mass of the earth is ME. The distance between P and center of mass equals to RE. The distance between P and center of mass is equals to RE. Next, when we consider the point P inner side of the earth at a depth D, the distance between the total mass of this inner shells, total mass of inner shells is capital MR. MR is nothing but the mass of the inner shells at a distance R from the center. Next, the distance between point P and center of mass is equals to small r. This is when we consider the point P inner cell. Now see. Here this is the R. Now see. When we consider the point P on surface of the earth, the gravitational force acts due to the center of the mass of the earth on this point P. Means between these two bodies, between the center of mass and point P, some gravitational force is acting. According to universal law of gravitation, What is the statement of universal law of gravitation? The statement of universal law of gravitation is, in the universe, every object attracts by the another object with some force. Every object. For example, here I am considering two objects. This is the mass m1. I am considering one object. This is mass m1. I am considering one more object is here. This is mass m2. So between these two objects, some distance is there. That is r. Already initially I told, every object attracts by the another object with some force. Here also, these two objects are attracting each other with some force. This force of attraction between these two objects is directly proportional to product of their masses. And inversely proportional to square of the distance between them. Universal law of gravitation statement is, the force of attraction between any two objects is directly proportional to product of their masses and inversely proportional to square of the distance between them. It It means if the mass of the first object is increased, automatically gravitational force between them also increases. In the two objects, if mass of any body is increased, automatically the gravitational force between them also increases. And if the distance between these two objects is increased, then the gravitational force between these two objects automatically decreases. That is directly proportional to product of their masses and inversely proportional to square of the distance between them. From these two equations, we can write as F is directly proportional to m1 m2 by r square. From these two equations, we can write as F is directly proportional to m1 m2 by r square. Here, if we want to remove proportionality, we have to take one constant. We have to take one constant. Now I want to remove this proportionality. If we want to remove that proportionality, we have to take one constant, that is capital G. Capital F is equals to G m1 m2 by r square. Here G is called as universal gravitational constant. Universal gravitational constant. Gravitational constant. Capital G is called as universal gravitational constant. It has one particular constant value. That value is equals to 6.67 into 10 to the power of minus 11 Newton meter square kg power minus 2. This is the gravitational constant value. It is the constant, does not change anywhere. So here G is the universal gravitational constant. M1 is the mass of the first object. M2 is the mass of the second object. R is the distance between them. This is the take as equation 1. Here in the first case, when we consider an object on the surface of the earth, some gravitational force acts between the center of mass and point P. So according from this equation, here mass of the earth is here. Initially I am taking this first case. What is the first case? The object is considered on the surface of the earth. This is the one object. This point P is one object. This center of mass is another object. Why? Because total mass of the earth concentrated at the center of the earth. So this is one object. This is another object. So here M1 I am taking first. When an object on the surface of the earth, total mass of the earth, m1 equals to me. First body mass is mass of the earth, total mass of the earth. Second body mass is point P mass. Next, what is the distance between these two? Radius of the earth only, right? R equals to R. Now substitute these values in first equation. Now from first equation, G me small m by r square. This is equation number 2. This is first case. Next, second case also there. When an object is considered, I am writing second case. This is the first case. When an object is considered, when an object is considered inside of the earth, inside of the earth, inside of the earth, at a distance or from the surface of the earth, from the surface, from the center of the earth, center of the earth. Here, when we consider at a distance r, the gravitational force acts on this point P due to the mass of this r region only. So radius in this inner side of this point P, mass of the earth, inner side of this point P only the gravitational force acts on this point P. Now from that m1 equals to mr. Why? Because this mass of this inner region I am taking as mr. This total is me. But when an object is inside of the earth, due to this total mass, the gravitational force does not act due to this total mass of the earth. But due to this inner side of the earth only, the gravitational force acts on this point P. That is why I am taking this inner mass, that is m1. Next, m2 is point mass m. Next, radius. The distance between these two is substituting equation 1. This value is substituted in equation 1. If we substitute f equals to g mr small m by r square. This is the equation 3. This is the equation 3. Next, generally if we take any object, it has some density. Here earth also has some density. Actually the density of the earth is equals to 5.51 gram per centimeter cube. This is Celsius unit of density, of the earth. SI unit of density of the earth 5515 kg per meter cube. This is the SI unit of density of the earth. So here, and generally we know the density formula. What is the density formula? Here earth, why I am taking density? Here earth has some density. So from that is here I am taking density formula, that is mass by volume. If we take total earth, that becomes mass of the earth by volume of the earth. So from this we can write mass of the earth equals to density is denoted by rho. Density is denoted by rho. So from this we can write rho v. M is equals to rho v. Already we discussed. What we discussed? M equals to rho v. Volume of the. Already we discussed earth is in the shape of the sphere. Earth is in the total earth is in the shape of the sphere. Sphere has some volume, right? What is the volume of sphere? What is the volume of sphere? Volume of the sphere is equals to, what is the formula for sphere? Formula for volume of the sphere is 4 by 3 pi r cube. 4 by 3 pi r cube. This r is nothing but radius of the sphere. 4 by 3 pi is constant. 4 by 3 pi r cube. Here volume of the earth is equals to, why I am taking sphere formula? Why? Because earth is in the shape of the sphere only. Initially we discussed that only. 4 by 3 pi r v cube. mass of the earth is equals to rho into 4 by 3 pi re cube. 4 by 3 pi r cube. From this we can write as ma by re cube equals to rho 4 by 3 pi. Now this is the mass of the earth when object is considered on the surface of the earth. When object is considered inside of the earth, density formula mr by, when an object is considered inside of the earth at a depth d, at a distance r from the center of the mass, the density of this region, this mass of the earth is equals to mr by vr. mr by vr. Now see, rho equals to mr by volume. This is also in the shape of the sphere only. This region also is in the shape of the sphere only. So 4 by 3 pi r cube. From this we can write as mr equals to rho 4 by 3 pi r cube. Pi r cube. Now see, this is equation 3. Equation 2 rather. Okay. mr value substitute in equation 3. mr value, this mr value, which mr value, this mr value substitute in equation 3. What we will get? F equals to g, mr value, rho 4 by 3 pi r cube into m by r square. Square to get cancelled, remaining one will be there. F equals to g rho 4 by 3 pi into m. Here rho 4 by 3 pi value, rho 4 by 3 pi value, me by re cube. me by re cube equals to rho 4 by 3 pi. Substitute. F equals to g rho 4 by 3 pi. me by re cube into m. Here remaining one r is there, right? R into m. Here also r into m. F equals to g me by re cube into r into m. If this r here this r is I am considering as re. This r I am considering as re. If we consider this r becomes re, F equals to g me by re cube into r into m. So this re get cancelled, remaining square will be there. F equals to g me by re square into m. Here we know one formula, that is normal force formula, F equals to mg. We know one formula, F equals to ma. Actually force equals to product of mass into acceleration. But when an object is moving due to the gravitational force of the earth, when an object is accelerating due to the gravitational force of the earth, A becomes G. A becomes G. Why? Because here the gravitational, due to the gravitational force only that acceleration is taking place. That is why this A becomes G. Substitute here. F equals to mg. From this we can write as G equals to F by m. Substitute this F value in this G equals to F by m. If we substitute the value G equals to G me by RE square into m by m. G equals to this F value I am substituting in this equation. F becomes G me by RE square into m by m. This m get cancelled. So now G equals to G me by RE square. This is the acceleration due to gravity of the earth form. With the help of this formula, we can find the gravitational force of a particular planet. This gravitational G formula we can apply for any planet. For finding the gravitational force of that planets, we have to know generally this we can write as G equals to G m by r square. Here m is nothing but mass of the earth, r is nothing but radius of the earth. Here G is nothing but gravitational constant. This is the constant value, does not change anywhere, that is 6.67 into 10 to the power minus 11 Newton meter square kg power minus 2. But here m is the mass of the any planet. Which planet you want to take, you can take. Which planet mass you want to take, you can take and substitute here, and radius of that planet substitute here. Then you will get the gravitational force of that planet. Now, if we substitute, okay, I am writing this. Generally, we know already if we take mass of the earth, general mass of the earth is equals to 6 into 10 to the power of 24 kgs. This is the mass of the earth, 6 into 10 to the power of 24 kg. Next, radius of the earth, Six point four into 10 to the power of 6 meters. 6.4 into 10 to the power of 6 meters, and G equals to 6.67 into 10 to the power of minus 11 Newton meter square kg power minus 2. If we substitute these values in that, F equals to 6.67 into 10 minus 11 into 6.4 into 10 to the power of 6 into 6 into 10 to the power of 24 kgs. Sorry, wrong there. F equals to 6 into 10 to the power of 24. F equals to G value. First of all, we should substitute G value. 6.67 into 10 to the power of minus 11. G into 6 into 10 to the power of 24 kgs by 6.4 into 10 to the power of 6 meters. I think this radius value is wrong. I forgot about this. Okay, leave out this. If we substitute g value and mass of the earth value and radius of the earth. In this equation we will get the acceleration due to gravity, acceleration due to gravity of the earth, that is G equals to 6.67 into 10 to the power of 11 Newton meter square kg power minus 2. Mass of the earth is equals to 6 into 10 to the power of 24 kg. Radius of the earth equals to 6.4 into 10 to the power of 6 meters. If we substitute these values in this equation, we will get G value 9.8 meter per second square. This is about the acceleration due to gravity of the earth. Here again two cases are there. When the object is on the, above the surface of the earth at a height h from the surface of the earth, and when an object is inside the earth at a depth d from the surface of the earth. So the two cases are so there. Okay, we will discuss later. Thank you.